Hello everyone, this is Professor Keene. We've been looking at Chapter 3 in a Student's Guide to the Grade Physics Text, Volume 3. In this chapter, we've been exploring the work of Benjamin Franklin. He has a series of letters or correspondences that are assembled into his experiments and observations on electricity. In our last lecture, we were talking about his second letter, which is on page 35 and 36 and the following pages in a Student's Guide. You might recall how we focused on a paragraph that was in the middle of page 36, where Franklin talked about the wonderful effect of pointed bodies, both of drawing off and throwing off the electrical fire. And then he provided some examples. Interestingly, this leads to his eventual development of the lightning rod that he'll be talking about in one of his subsequent letters. We also talked by the end of that on page 37 about how the sun thrown on a charged object is not able to discharge it even if one uses a magnifying glass, and how this would eventually, a re-exploration of this topic would eventually lead to the quantum theory through the photoelectric effect. We stopped there, and on page 37 I want to make a few more comments on Franklin's discussion of the reason why objects are electrified. And he mentions here that he thinks that electrification is a material cause. This is evocative of the language of Aristotle and the medievals and the scholastics, and even of Gilbert, who talks about material causes and formal causes. You might recall that Gilbert described magnetism as a formal cause. That is, the Earth gives the form of magnetism to rocks that are residing in its bowels. He said that because magnets, if you weigh them, do not increase in their weight whatsoever. So there cannot be an additional magnetic material that's added to them in magnetizing them. Rather, they become magnetized through a formal cause. Gilbert also mentioned how he believed that amber and other electrical objects, when you arouse electricity in them by rubbing them, for example, they acquire a new material cause. That is, he believes that there's actually some material that enters into them and then can be thrown out of them when they provide shocks. This kind of makes sense, especially given Franklin's work where he describes how an object gets electrified. Franklin describes it as electrical fire entering it, and then when it discharges, there's electrical fire that leaves it in the form of a spark. So the notion is that while magnetism is a formal cause, electricity is a material cause. There's further evidence that Franklin provides of this when he talks about if you take a spherical object that is charged up, like an iron ball, and you put a needle on top of it, and on top of this needle you can place a piece of paper with little fins coming off of it. I have something like this in my research laboratory. It's like you put little fins on this and balance it on top of this needle, and when you charge this up, what happens is this object spins around. And why is that? Well, because in Franklin's view, there's electrical fire being ejected or thrown off kind of like a sprinkler from this. And since that carries momentum, that's not the language that Franklin uses, but you might imagine later on people using this language. When you have this electrical fire being spewed out of the tips and the thing spins around, they carry momentum, and that's what gives this spinning paper object angular momentum. So anyhow, I thought that was an interesting comment that he makes down here at the bottom of page 37. Let's go on to the next page, and here Franklin describes some of his experiments with people standing on wax insulation. So let's draw a picture here of his conception, rather these experiments that he's talking about. So there's experiments with subjects or people standing on a wax mat or a wax platform. Okay, so this is once again on the top of page 38. You might imagine some wax right here. This is a wax platform. It's sitting on top of the floor. And then you have two people that are standing on this wax platform. The wax, it acts as an insulator. It prevents, if they get electrified, it prevents them from discharging to the floor. Let's call this person person A, this person person B, and then you have a third person, C, who is standing on the floor. Person A, Franklin has hold on to one of these glass tubes, and in the other hand they hold a piece of silk or leather. And what happens is they rub the silk across this, and when they do that, the silk and the glass rod becomes electrified. And he's going to provide evidence that not only is this electrified, but also person A is electrified, but in a different sense. We'll come back to this in a moment. Okay, so what happens is, first of all, person A rubs the glass with silk and becomes electrified. And then number two, person B draws his knuckle across the glass. Person B becomes electrified by touching the glass. So that person gets the same sense of electrification as the glass. Person B becomes electrified by rubbing the glass. How does he know that these people are electrified? Well, he says that if person A touches person C, there will be a shock. Also, if person B touches person C, there will also be a shock. And finally, if person A touches person B, then there will be an even bigger shock. So some of the observations, move this out of the way. Some of the observations are that, first of all, A can shock C. Number two, B can shock C. And number three, A can shock B. And this is a very strong shock, or strongly. How does Franklin understand this kind of thing? Well, what he does is he coins some terms here that become very important in the history of electricity. And this is, I'll highlight it right here. He says, hence have arisen some new terms among us. We say that B in bodies like circumstanced is electrized positively. A is electrized negatively, or rather B is electrical plus and A minus. So what he's saying here, I'll draw some letters here. When A rubs the silk against the glass, he says that A, rather the glass rod, becomes positively electrified, and the silk and person A become negatively or minus electrified. There's kind of a separation of charge here that's caused by the rubbing of the silk against the rod. When B then touches the rod, B also becomes positively electrified. So you can see now why if person C, who is neutral or unelectrified, touches A, then what happens is there is an attempt to reestablish equilibrium. So there is a shock between A and C. Likewise, when C touches B, there's an attempt to reestablish this equilibrium. So B and C shock each other. And finally, if A and B touch each other, there's once again this attempt to establish equilibrium. A and B can shock each other. How he conceives of this is that every object, so according to Franklin, and this is his theory of electricity, according to Franklin, all objects have some level of electrical fire in them. Or some fluid, you might think about it that way, electrical fire in them. Okay, so person A has some amount of electrical fire, B and C likewise have electrical fire. And same with this rod right here. But when there's rubbing, what happens is some of the electrical fire rubs off, and the glass rod in this case gets an excess of electrical fire, and it gets it from the silk rod and the person. So what happens on rubbing is there's an accumulation of electrical fire in object A. That's what we call positive electricity. So positive electricity or positive electrification implies that you have an excess of electrical fire. Excess of electrical fire in Franklin's conception. What do we mean by negative electrification? That person or object, if it's negatively electrified, it has a deficit of electrical fire. Let me move this out of the way. Of electrical fire. And a shock is essentially an attempt at equilibration. That's the process of equilibration of the electrical fire. Notice he's not thinking about this as in modern terms as positive charges and negative charges as objects themselves. Rather, he's thinking about this as some fluid that fills all things. When it acquires an excess of that fluid, an excess of electrical fire, it's called positively electrified. When it has a deficit, it becomes negatively electrified. And whenever things come into contact, they try to equilibrate at some level, and that's when they would be called neutral. This is a sense in which Franklin is using the terms positive and negative electricity. By the way, this is a convention that he adopts. He says if you rub glass with silk, we will call that positive electrification. It's not like you see little positive numbers or positive signs on that piece of glass. All you know is it shocks things. So he says we'll denote that the glass to be positively charged. We'll denote silk to be negatively charged when it rubs glass. On the other hand, by the way, if you take some kind of rubber or plastic and you rub it with fur, that becomes negatively electrified, and the fur with which you rub it becomes positively electrified. We'll say more about this in the coming lecture, but for now, why don't we stop?